Next, we will create a Bastion host on the public subnet. From the AWS dashboard, select EC2. Then, select the Launch Instance button. Select the Amazon Linux AMI, which should be the first selection. We will select the T2 micro instance, and this is covered by the free tier. Then click on Next. On the next screen, we will select the DevOps Buddy VPC as network, the public subnet in EU West 1A, enable as auto-assign public IP, and we'll select DevOps Buddy -full as IAM role. We can leave everything else as is and click on Next. We can leave the storage as is and click Next. In the tag screen, we can set Bastion host as name. Then, we can add a visibility tag with value public and click on the Next button. In the security group window, we should select the Bastion host security group that we have set up in the previous lecture. Then, we can click on the Review and Launch button. Finally, we can click on Launch. Next, you will be asked to select a key pair. If you already have a .pem file, choose an existing one, but please make sure that you do have the PEM file stored locally. Otherwise, select the option to create a new key pair and download the PEM file locally. Tick the acknowledgement checkbox and click Launch Instances. I'm now going to pause the video as this process might take some time. Now that the instance is up and running, we will add the PEM file to the list of SSH authorized keys so that we don't have to define it all the times when connecting to an Amazon box via SSH. To do this, locate the PEM file that you have specified when launching the instance. Open a command prompt and point to the folder containing this file. Then type the following command: ssh-add -K and then the full path of your PEM file. In my case, I use the following command: ssh-add -K /.sh/devopsbuddy.pem. Now, on the AWS console, locate the Bastion host public IP address. You can find this in the bottom half of the screen. Copy this address to the clipboard. Now, open a command prompt and type the following command: ssh-ec2-user and then the public IP address that you have just copied to the clipboard. Type enter when asked to add the IP to the list of known hosts, and you should be able to log in to the Bastion host box. Great, we can SSH into the Bastion host. Now, we need to verify that our security group setup works properly. Before doing this, please make sure that the VPC has got a NAT gateway attached to it. If at the end of the previous lecture you have deleted the NAT gateway, just create a new elastic IP address, then a new NAT gateway, assigning the newly created elastic IP to it. As subnet, choose one of your public subnets where to run the NAT gateway. I chose public subnet EU West 1A. Make also sure that you replace the newly created NAT gateway in the root table for the private subnet. Now, to launch the Spring Boot instance, from the EC2 window, click on the Launch Instance button. Again, select DevOps Buddy as VPC, only this time select the Spring Boot EU West 1A subnet, or whatever subnet you have set up for Spring Boot if you are running in another region. For the auto-assign public IP, choose Disable. For the IAM role, choose DevOps Buddy -full. Click Next twice, as we are happy with the storage options. On the tag instance window, give a Spring Boot server as name, and then add a new tag named Visibility with value private. Once done, click Next. As security group, choose Spring Boot SG and click Review and Launch. Finally, click on Launch, selecting the same key pair you have selected from the Bastion host. I'm now going to pause the video as this process might take some time. Okay, now that the box has been created, we can progress. Since the Spring Boot instance is on a private subnet, it doesn't have a public IP address, which means we can't directly SSH into it. This is why we have created the Bastion host. We now need to verify the connectivity between the Bastion host and the Spring Boot application. To do this, open a command prompt and type the following command: ssh -A ec2-user @ and then the public IP of your Bastion host. The -A option instructs the SSH agent on the Bastion host to act as an agent, so that we can now directly connect from the Bastion host to a box running in the private subnet. To test that this works, from the Bastion host type the command ssh and then the private IP address of the Spring Boot box. You should be able to connect without issues. Now, we will install MySQL on the Spring Boot box with the command sudo yum install -y MySQL. We will use this to connect to the MySQL RDS instance that we will be setting up later on. Next, we will remove the current Java 7 version with the command shown in the video. Please take a moment to pause the video and type exactly what you see. Finally, we will install Java 8 with the command sudo yum install -y java -1.8.0 openjdk.x86_64. All these commands are included in the file springboot-init.sh, which I've attached to this lecture. We will see later on in the course how to use this file to initialize a box when it gets started. Now, we can check that we can connect to S3. First, we will need to configure the AWS command line with the command aws configure --profile DevOps buddy. Here, enter the same details that you have entered when configuring the DevOps buddy profile on your local PC. Basically, you should still have the .csv file that you have downloaded from AWS when creating the DevOps buddy user. As your default region, select the code matching your region. In my case, this is Ireland, which is EU-West-1. Be careful not to confuse the region code with the availability zone code. For the AWS region Ireland, the code is EU-West-1. Ireland has got 3 availability zones: EU-West-1A, EU-West-1B, and EU-West-1C. Make sure that you enter the region name and not the availability zone name. As for the format, you can enter JSON all in lowercase. Once done, type the command aws s3ls --profile DevOps buddy. This should return the 2 buckets that you have set up in your region. I've created some additional files to be placed in the S3 bucket. These are DevOps buddy, which is a startup script to start the application, and DevOps buddy.sql, which is the MySQL script to initialize the database. I've attached these files to this lecture, so please add them to your bucket. You can do so by adding them to your local .devopsbuddy buddy folder and run the AWS S3 sync command as seen previously, or you can add them manually from the S3 window on AWS. Now, we can run the command that copies the S3 bucket locally as .devopsbuddy. buddy. The command is aws s3 sync s3:/ your config bucket name space ~.devopsbuddy --profile DevOps buddy. This command should create a .devopsbuddy folder under the EC2 user home folder with the S3 files in it. Make sure to secure this folder content with the command sudo chmod 600 ~.devopsbuddy / and the command sudo changemod 700 ~.devopsbuddy. Great! So far, we have verified that we can SSH into the Bastion host and from there to the Spring Boot box running on a private subnet thanks to the SSH agent. We have also verified that we can connect from the Spring Boot box to S3 and to the outside world thanks to the NAT gateway and the S3 endpoint that we have set up when creating the VPC. Now, we want to create another box in the public subnet for the Apache HTTP server. From the EC2 console, we can launch another Amazon Linux AMI of type T2 Micro. We will select DevOps Buddy as VPC, the public subnet EU West 1A as availability zone, enable as auto-assign public IP option, and DevOps Buddy -full as IAM role. In the tag window, we can name this instance HTTP server, and for the visibility tag, provide the value public. These tags will come handy later on when we will be managing our infrastructure with Ansible and Bash. As security group, we should choose the public SG that we have created in the previous lecture. Finally, leave everything else as is and launch the instance. I'm now going to pause the video until the instance has been created. We can now verify that we can SSH into the newly created box by copying its public IP address and entering the command ssh ec2-user @ and then the public IP address of this box. We can also install the Apache HTTP server on this box with the command sudo yum install httpd-y. Once installed, we can start the server with the command sudo service httpd start. You can then test that the HTTP server is reachable from the internet by entering the IP address in a browser. The Apache HTTP default index page should show. The final step in this lecture is to set up the MySQL RDS database. From the AWS console, click on the RDS and then on the subnet groups link on the left menu. Create a new subnet group and call it DevOps Buddy -subnet -group. In the description, enter DB subnet group for DevOps Buddy. As VPC ID, select DevOps Buddy. As per our architectural diagram, select EU West 1A as availability zone and the subnet ID with CIDR 10.0.5.0/24. As a reminder, just for the purpose of this course, we have selected only one availability zone for MySQL database. However, in a production setup, you would want to install the RDS instance on at least 2 availability zones. However, RDS requires a minimum of 2 availability zones to set up subnet groups, so we will need to select another availability zone by doing the following. Add another availability zone. I'll add EU West 1C and assign to it as subnet ID the value of the private subnet with the CIDR 10.0.3.0/24. Once done, click Create. Now, from the RDS dashboard, click the Get Started Now blue button. Select MySQL as database and then select the Dev Test option. As you can see, this type is meant for usage outside production and within the free tier. As DB instance type, select db.t2.micro, which is the one covered by the free tier. For multi-availability zone deployment, select No and leave the allocated storage to 5 GB. In the settings, enter DevOps Buddy for the DB instance identifier, the username and password. Obviously, in a production setup, you would choose different values, either for the username or the password. In the network and security screen, select the DevOps Buddy VPC in the DevOps Buddy subnet group. Leave publicly accessible set to No and choose the availability zone as per our architectural diagram. I'll choose EU West 1A. Finally, as security group, select the RDS security group that we have created in the previous lecture. As database name, select DevOps Buddy. As backup retention period, select 0. Since this is a test database, we don't want to back it up as there is a cost associated with storage if we do. Leave everything else as is and click on the LaunchDB instance. I'm now going to pause the video as this operation takes few minutes to complete. We resume when done. Now that the DB has completed the setup, you will notice an endpoint. This is the DB URL that we will need to use in our application to connect to the database. We can now test the connection from the Spring Boot box to MySQL. First, we will need to connect to the Bastion host as we've done earlier with the command ssh -A ec2-user at and then the public IP address of the Bastion host. Then, we will SSH into the Spring Boot box private IP with the command ssh and then the private IP address of the Spring Boot box. Since we have installed the MySQL client, we can run the command MySQL -h and then the endpoint URL from RDS without the colon and the port 3306, -u DevOps body, -p and then press enter. When asked for the password, enter DevOps body and press enter. Now you should see a MySQL prompt. The first thing we need to do is to enter the command use DevOps body semicolon. This command is to use the DevOps body database that we have created during initialization. Now we will execute the MySQL script that creates the database and initializes it with reference data. To do so, admitting that you have placed the DevOps body.sql script under the ~/.DevOps body folder, you can enter the command source ~/.DevOps body/DevOps body.sql. Congratulations! You have just set up the DevOps body database with the tables required by the DevOps body application on a MySQL database running on Amazon RDS. We will stop here for this lecture. In the next lecture, we will configure Apache HTTP to redirect traffic to the internal Spring Boot application. We will deploy the DevOps body application on the Spring Boot box, and we'll try our application on a single box configuration. Thank you for your time, and I see you in the next lecture.